Hi everyone, I'm Lior Sidi. I'm leading the AI research team, one of the AI research team here at Wix. And today we're going to talk about how we actually customize LLMs for the Wix domain. Okay, so welcome here. Pleasure to host you here. If you haven't checked around, so feel free then maybe to check the restroom on the right. I think it's one of the coolest one that I've seen. So great having you here. Now, let's jump into the details here. When I, as a Wix data scientist researcher, talks about AI at Wix, many people ask me, wait a minute, why you need AI at Wix? Where it starts from, what you're actually doing. So that's why, before we start, let's have this.
The future of your business is here. With Wix, you get advanced AI capabilities for more customization, more time, and more growth. Speed up your website copy with an AI text generator that delivers a consistent brand voice to every corner of your site. Unlimited unique visuals enhance every piece of content you create. Instantly transform any idea into an image right from the comfort of your platform. And win back hours of hard work with AI-powered emails designed to perform. More conversions, less hassle. Smart benchmarks show you exactly where you stand in the market. See what's working and what needs work so you can quickly spot your next opportunity and take your business where you want to go. Oh, and we're just getting started. Go to Wix.com and make it happen.
Woo! So you can imagine this is just a PR video. There's much more that we are doing beyond that. As Gilad mentioned, we are doing, since 2 years ago, the Gen AI revolution, it really scaled up because Wix, in the end of the day, you're building website, you create a lot of content, and this kind of technology allowed us to scale even more. And we invested a lot in platformizing many of these capabilities to our developers, our product managers, to have much more AI at Wix than before. But we do hold a very strong and very smart data science research group at Wix already since 2015. And this is what actually allowed us to scale, and this is what actually now allows us to go deeper, to have better AI capabilities, which are a bit more advanced, a bit ahead of the curve. Basically, we want more. So, it's working? Okay. So when it comes to LLM customization, there are different aspects of it, okay? Different techniques that we can apply. The most basic one, which is not that complex, but it's very, very constrained, is the prompt engineering. Most of you know, no need to talk more about it. When you go with a bit more complex solutions, but have a bit more capabilities, you have the augmentation using RAG, where you retrieve an article or information, create a context, put it in the prompt for LLM, and then generate an answer. So that's the RAG augmentation capability. And then you have the entire landscape of fine-tuning. In fine-tuning, we differentiate between two. The first one, which most of you, I think, know, is what we call task/prompt fine-tuning. This kind of capability, it was what is accessible with most of the vendors like OpenAI, Anthropic maybe, I think. So they allow you to do a specific prompt fine-tuning. Okay, you give a prompt, you give a small sample of data, and you fine-tune for this specific task. Where it becomes more interesting is when you want to train the LLM or fine-tune it for multiple tasks at the same time, or you just want to train it from scratch, so the model will understand your domain, what we call domain adaptation. All of these techniques sort of have domain adaptation capabilities, but when you really fine-tune for multiple tasks from scratch if you want, so you really get a model that understands your business better. Now, before we start, just want to clear it up. We have the pros and cons doing that. The good thing is when you fine-tune or apply domain adaptation, you actually get a model with much fresh data, updated data of your model. You can have, if you use it locally, you can have much faster, you can reduce the latency, and you can use it for, some privacy local things that you want to test, and you don't want to share data outside. So, that makes sense. The not so, why not so you don't want to go with the domain adaptation is, first of all, as I'm going to present today, it's not that easy. It's quite hard. It's expensive. You need to waste money not only on the training itself, but mostly on the data curation and understanding how to do that. And lastly, is that you really want to rethink if you're going to domain adaptation, because currently we see, and you see it as well, LLM, the proprietary one, as is, have very good performance. Okay, so just keep it in mind. Cool. So when we investigated different works that, as a research group, you cannot start without doing some related work. One of the first works that was done by Bloomberg GPT for Finance when they domain adapt their LLM. Very simply, just took a bunch of financial data, trained a model from scratch, an empty LLM, and had a model. Very straightforward, very simple. Then came NVIDIA. NVIDIA did something cool. So first they had the domain data. They wanted to adapt the models, they call it Chip Nemo, for the chip industry, for hardware. So it will know the chip industry domain, apply some tasks on it. So what they've done, they use the pre-trained LLM, they continue training it with domain data, and then they applied supervised fine-tuning, what we call also instructive fine-tuning on some domain-specific tasks, which is with much less data of the domain, only 1.4K different records of this task, and they still also added general data sets with general tasks, so the model won't forget previous knowledge. So there is something called extreme forgetness. When you fine-tune the model, again, only on your domain data, it might forget previous knowledge, and you don't want to do that. So either way, when you do that, you want still to have some general data in your data set. So these are two techniques that, very core domain adaptation for specific domains. One is for chip, and the first one is for finance. But an interesting work that really influenced us was reading comprehension by Microsoft, our friends here. What they've done in reading comprehension, it's basically taking the raw data, the textual data of a domain, and extract reading comprehension tasks out of it. For example, given an article, generate the title, right? Given the article, please finish it. So these are the different reading comprehension tasks that they have applied. One of the most interesting tasks that they have done is they identified paragraph that contains a lot of the domain terms and words, and ask the LLM as a task for training, please extract a paragraph that talks about these terms, and this was the output. So this is how they use reading comprehension to train a model. But how we can apply all these things for Wix, okay? So there are also many other works. By the way, this work was finished 6 months ago, and so it might be a bit not so updated, and there are many works since then. But we needed to understand back then, okay, we see that, how we take it to our domain. So first we need to identify what we have and what we don't have at Wix. So we don't have billions of tokens. And it's not only us. Most of your companies probably don't have billions of tokens of data that you can share outside. We have a lot of data that we can use internally, but if I want to have it a bit externally, I don't have billions of data. On the other hand, LLMs already knows Wix and knows website building and different features that we have. We tested it, and you're going to see with the benchmark that we've created. So overall, LLMs, pre-trained LLMs knows Wix, that's cool. On the other hand, we at Wix already have a lot of high-quality data from our companies, especially with previous projects that we were doing in the data science. So we have a lot of curated data, and it's very easier for us to do that. So that's also a main advantage that we have. So how we combine everything and come with an architecture we want to follow? Basically, what we've done, we took reading comprehension setup and created a lot of instructive tasks as a data set and fine-tuned in a supervised training manner with an instructive training. Okay, that's the setup. Make sense? Okay. So in high level, these are the main components that we're going to talk about today. We have the raw data sources on the left. That's a huge effort that you want to do, and we're going to talk about it as well, mapping different sources that you can use for training LLMs. Then these data sources can be used in two ways. The first path is for training, creating training data sets at scale and fitting the model. And the second one is an evaluation flow that allows you to estimate the performance of your LLMs, of your models, right? When you want to start a project, I recommend you, as a common best practice from data science, is to start with the evaluation. And the evaluation is critical here. You want to start with evaluation. You want to have the end-to-end understanding what's the current state of the performance of your models. Usually, when we, as data science group, we help other companies at Wix when they are doing, engineers want to build their own model, the main things that we see is that they don't start with evaluation. It's come very late. What it causes that you don't know really the performance of your model. You don't know what you're optimizing for. You don't know when to stop or when to start, basically. So let's start with the evaluation. And in evaluation, one of the coolest techniques that we saw by reading comprehension and also in other project called LLaMa is that something called knowledge probing. Knowledge probing is when you take a question and answer, and create a quiz, a multi-choice quiz. That allows you to estimate the performance of knowledge in a very easy manner. So you have like a multi-choice questionnaire, A, B, C, D, what we call an American test in Israel. And then you can get two things. First, you get a stable evaluation of the knowledge, because it's not that you ask to generate a full text, right? Evaluating for a full text, as we're going to discuss, it can be very, very tricky and very, very hard. The second thing that you can estimate the performance of the model to follow instructions. So you get two things. And the question is how you actually extract out of this pair that we already have of question and correct answer, how we can extract this quiz. So what we've done, we created a prompt, and together with manual inspection of our data curation team, we created three options, one each which is very easy, another one that is hard, and another one that is harder. As it comes harder, it makes more sense, for the model. One of the important things here when you're trying to create such a quiz is to make sure that the answer that you generate are in the same structure of your correct answer, so you won't fall in structure elements, okay? So that's for knowledge probing. That's basically one of the first tasks we want to estimate the model for. So we have here three knowledge-based tasks. This entire project was all around customizing LLM in respect to knowledge. So we have these three tasks. The one that I just mentioned, which is multi-choice quiz, that you just see did the model select the right answer. Another one that we took intent classification, which is a data set that we have from the chatbot of customer care, that basically we see the conversation of a user and a chat or a customer care agent, and we classify which intent the user have in respect to Wix. So it's basically a classification task, and it's another way to estimate how knowledgeable the model is on Wix. And the last one is the Q&A in free text. So the question is, okay, you have the three, how you quantify the metric out of them. So for the first two, it's really stable. It's accuracy, F1 score, you have one-to-one answer, right? It's very stable. As I mentioned before, for Q&A, it's a bit more tricky. The way you can, for Q&A and basically any other generated text or even image, it's become a bit more tricky to estimate the performance of your model. You can do it manually by a human, but it's actually not scalable, meaning that for every version, you need to do it again and again, so not for us. The other approaches, like exact match, similarity, or some score, are very, very limited when it comes to long answers or short answers, so they're not that stable. And our Q&A are much longer. They can be much longer. So I don't know if you know, there is another option to do that, and that's LLM as a judge. LLM as a judge is basically you let the LLM to decide for you whether the answer was correct or not. But despite the fact that there are many good results in research, we were not satisfied from that because we really want to make sure that these kind of LLM as a judge can work on our use case. So what we've done, we created a benchmark, a data set of, we took LLM GPT-4 and extracted candidate answers and gave a human expert to decide whether the candidate answer and the gold answer, that is correct answer, is correct. So we have a lot of data that humans said that whether it's right or wrong. And then we also had the LLM as a judge with a simple prompt that you can see here. That's the prompt that is provided mostly by most of papers out there. User question, gold answer, is the candidate similar to the gold answer or not? And when we compare the agreement between the human expert and the LLM as a judge to see if it makes sense, we saw that it's have only 50% agreement, meaning that the LLM as a judge not really agree with our human expert, so we don't want to use that. So what you can do? What you would do in this case? Fine-tune, you can fine-tune it. You can fine-tune the LLM. What else? Use another LLM? No, maybe. Change the expert. No, the expert were doing very good things. Fine-tune. Just create a better prompt. Yeah, exactly. So exactly. So we just improved the prompt, and by improving the prompt, we got much higher agreement. So that's, we're talking with researchers here, so maybe we don't like to talk about prompt engineering too much, but prompt engineering is a great tool here. You start with giving a description about the problem, about Wix in general. Then you give it the instruction for solving the task, and then the output. What we have identified in the error analysis that we've done is that usually the LLM as a judge was mistaken when the provided answer was too long, okay? Add some extra information. So what we've done, you can see it in point 2, we added different criteria of what might, different criteria of long answers that can happen. It can be because of equivalent answer, it can be extra information, it can be a partial answer. So we made sure that the LLM is aware of these criteria and asked them to also give it. And also, that's the final prompt. We had a lot of iteration around that. And the main thing that we were looking at, this is a tip for you, is the false positives. So what you have here, you have the confusion matrix between LLM as a judge and expert as a judge, and you can see that when the expert says that it's not equivalent and the LLM as a judge say it's equivalent, the dot, something that the 2% red box over there, So this is the false positive we cannot have in our system. So when LLM says that it's equivalent, that it's actually a good answer, but in fact it's not. So our goal, we all the time look at that metric, not necessarily the agreement, and we wanted to make sure that this is being reduced to a number that we feel okay. The other type of mistake, when the LLM as a judge says that it's not equivalent, but it actually is, it's when the LLM as a judge is a bit harsh than human, and we can live with that. So that's overall when we created our evaluator. We didn't see a lot of work around it, so we felt that it's very important to share it. Also, by the way, another note that we also estimate it on GPT-4, which is a very strong model, but we also estimate it on LLaMa 7 billion, and if you estimate it on open or very weak models, like LLaMa 7 billion, actually, it was very easy to LLM as a judge to identify bad answers, right? So the agreement was higher in case that the answer were bad, very bad, like in LLaMa 7 billion. Okay, so moving ahead, we have evaluated all the baseline models with on our benchmarks and our quizzes. By the way, we are using these benchmarks as well today to estimate other LLMs when we come into understanding which LLM might be relevant for Wix. And we can see here that GPT-4 really outperforms all the other models. And LLaMa 2 13 billion chats is actually very low. And the question we want to ask is, can we adapt LLaMa models to outperform GPT? Okay, that's where we stand. And now it's easy. Now it's easy for us to understand how we move forward, where we at, where we want to get improved. So let's start with the data. Data is all you need. We already forgot about attention. And let's start with the data sources. And data sources, it's really dependent, and each company has their own data sources and how they map them. We at Wix also have a lot, and when you want to quantify the relevancy for LLMs, we've done the following. So you see on the left, each row is a data source. I just picked 9, but there are more. We gave them some type of data source. So we have articles data source like KB, post, internal notes. You have conversational data source like live chat, Wix forms, raw live chats. And you have tabular data, which is huge, like a lot of tabular data that we use from our issue system, success platform, and also different data sets we had at data science that we used, okay, for training other models. So these are the rows, and in respect to this, to quantifying the relevancy, so first we start with quality, the size, the fresh, how diverse the data is, the value that we can get out of it, is it clean? And then the task efforts that we need to invest in order to create, a training data set or even evaluation data set, but how much we need to invest in this data to create tasks. So we fill the table, and that's allowed us to prioritize different data sources we want to start with, okay? In companies or organizations that have a lot of data sources and you don't know where to start, it's very important that you will do that. And that's actually, I can tell you that we selected based on the task efforts mostly, but also about cleanness, because we saw how difficult it can be when you handling very noisy data. So, how we, someone want to take a picture? Data is all you need. Let's see how we actually use this for training. Let's go now to the training part. Understanding how we're using it, this training for how we're creating from this raw data a training data set. And remember that we have 3 types of data sources. We have articles, conversational, and tabular. So for the articles, we used reading comprehension that we talked before from Microsoft. Here is an example. You have Wix article. We ask it to to given the content of the article, generate a title, giving some words, topics about Wix, generate a paragraph about these topics. So very straightforward, very easy to use. It's also open sourced. And for conversational and articles, we use LLM-based to augment more tasks. Um, and one example for it is where we took live chat and extracted Q&A. We just gave LLM to give in a live chat, extract Q&A. And there are many more tasks that we have applied there. And the last one, which is, back then it was pretty new, it's working with tabular data. So I don't know, it depends on the organization. There might be a lot of gold nuggets in your tabular data. And you wanna extract the most out of it, and you can actually use it for creating much more data sets that you have, like increase your data set dramatically. So for example, we took the issue system at Wix. We have an issue management system, and we just ask like factuals questions. For example, based on the user inquiry about certain issue, which Wix product does this question pertain to? Okay, and then the output is what we want the LLM to answer. Okay, so very easy to extract. I can tell you that it's very important to create a lot of templates for like different phrasing and templates in order to make sure that the LLM is not overfitted for certain phrasing. Okay. Another one is a recommendation system or actions or user actions at your system. So for example, here we have a user in a certain context that was offered different actions to do at Wix, and we have data that shows us which action he took and was it successful for the website or not. Okay, so we have this mapping, and we created a task out of it. Very cool. So once we have, for each one of the sources, we have what we call task augmentation process that augment these raw data sources into tasks. We have a lot of data, and we need to learn how to sample it, create some balancing, and then creating the training data set. So the idea behind balancing and sampling the data is that in the end of the day, we want to move the pre-trained model knowledge about Wix to a different distribution. So we have the amount of tokens that are relevant for Wix or our domain that exist, that the pre-trained LLM is aware of. We want just to increase the ratio, not that it will be 90%, but let's say 40%, even 2%, depends on your domain, compared to the general data. So it means that now that I'm creating a training data set, it needs to comprise from our domain tasks and the general data, so we won't get the extreme forgetfulness that I mentioned before. Okay? So this is more or less the numbers that we've got from each one of the data source, the data sets. Some of them were like very big, some of them were much lower. But eventually, this is a very important hyperparameter that we examined. And I can tell you that in some scenario, 40-60 worked. On another, in another scenario, maybe it was 1-to-1, even less. So that's an important hyperparameter that nobody's talked about it so much. So be aware of it, okay? We chose even, the 40-60, it was one of our experiments that works well. Okay, so now let's talk about the modeling. And I'm happy to have here our AWS friends that really helped us in making the training process available. We used SageMaker as a base together with Hugging Face to make this pipeline working. You need to make sure you have very strong machine when you go into LLM training. So first of all, you need to choose your base LLM. So we choose LLaMa 13 billion chat. The reason for that is that, first of all, we saw that LLaMa is being used by most of the domain adaptation papers. And we wanted the chat capabilities. We wanted still a feeling of interaction between the LLM and the queries. So that's why we started with LLaMa 13 billions. The reason for 13 billions is because the machines that were available to us back then were able to support 13 billion to fine-tune from for different kind of criteria, different kind of weights. And that goes to the second part, which is different types of training. You can do full or partial. I'm going to talk about it soon. Different kind of fine-tuning. And then evaluation. The evaluation part is very, very important, again. Also the matrices that I discussed in the beginning, but also manual inspection to identify issues in the output. So for the training, you have full weight fine-tuning that requires a lot of data and resources, what we had before called DAP, Domain Adaptive Training. And we have partial training, which is, if you know LoRa, you can train with much less data. You can train as well. And with LoRa, we also recommend using QLoRa, which allows you much faster training, bigger batches, and longer context. And that was critical for us when we fine-tune. I can tell you that we tried different variation back then. The one that worked for us and that was also allowed us to iterate fast was working with QLoRa only. But today, with the knowledge that we have today, it's not mandatory. I also will examine the other approaches as well, okay? Yeah. So, now that we have this flow of training and what we've done, let's see some of the, like when you start training, you start to see a lot of noise. So let's see them. So one of the issues that we tackled is repetition. Everyone that trained the LLM might saw that you have the LLM creating more repeated sentences. The way to tackle that, what we saw, is first of all, is that you want to separate between the end of sentence and the padding token that is not by default separated in LLaMa, so make sure in the tokenizer of LLaMa. And also you want to continue with more epochs. But I can tell you the issue with the token is one of the fundamental one. Another thing is the structure. So this 1, 2, 3, 4, 5, 8, it's like not something we want to get. We want to get a full answer sometimes. Sometimes we want it to be 1, 2, 3, 4, 5. So how you do that, how you can tackle that, create more templates, create more variation of your data set. In the end, what you put into the model is what you get outside. So we created much more templates to tackle this. Another one is instruction leakage, is when the LLM answer the task and then start asking itself another question and continue answering. This is what we call instruction leakage. And the reason for that is usually when we started, we backpropagate the model both on the input and the output. Okay, so what we've done is first of all we backpropagate only on the output. And also the token of end of sentence also helped what I said before. The beneficial thing about backpropagating only on the answer is that you really get stable results, you get only the answer. The bad thing here is that there is a lot of information about Wix, knowledge that exists in the input. So for example, all the context about the user, all the setup of the question, you also might want to learn from that. So we made a bold decision and decided to fine-tune only on the answer. Cool. So I don't have a lot of time, so I'll try to make it quick. So this is the final results that we've got. This is our model. So when we mentioned that it's outperformed GPT, we meant GPT 3.5, not 4. It was very hard to outperform GPT 4. And also by a bunch, like not a lot. And also, you need to remember that the LLaMa 13 billion is much smaller model than GPT-4. That is number of parameters still, for me, it's unknown. So that's very interesting. Basically, what we've done, if I'm wrapping it up, so we extracted a lot of data from a lot of instructive data from our raw data with different task augmentation techniques. We trained the model using QLoRa. We got better. We of course improved LLaMa 2 13 billion chat with that. And you can see also that we've done the fine-tuning on GPT 3.5 fine-tuning. And actually, the performance of GPT 3.5 reduced. Any idea why? The model too big. So the fine-tuning of GPT 3.5 is done by OpenAI, and it's basically done for one task at a time, right? So, and on a small data set. So when we brought it a lot of data from different tasks, it actually made it worse, right? That makes sense. So you don't want to use GPT 3.5 fine-tuning if you have multiple tasks and too much data, okay? So what we've learned that first of all, if I would have more time, I will invest in data, in cleaning it, making it ready for training. Even if you don't have billions of tokens, you still can fine-tune some models with your millions of tokens. Just make them, correct and clean. And you don't want to build the next GPT. You just want to build an LLM that is aware and accurate on your domain. So keep it in mind. Looking forward, our team decided to focus more about knowledge. And knowledge is a huge area that is now explored, and recently many papers have published around it. It's how to create LLM-friendly context for RAG, how to fine-tune RAG for creating much more accurate answers. So this is specifically my team, but also other research teams in the group are investigating code generation, automatic design, and automatic evaluation, and the list goes on, just exploring this area. So this entire work couldn't take place without the amazing team. As you can see, this project is not consisted only from researchers and data science. I can tell you that the work balance was, not evenly distributed, but the data curation, as you saw, it's a lot of data here. Were a major player in this project, and it started from the from evaluating the evaluator and creating the benchmark and manually inspecting it. Data curation, if you don't know, it's a role we have in our group that is responsible on the quality of the data and the model results. It's basically an AI analyst that understands our work and allows us to scale the work of the research and the models that we are working, because we're working on a lot of data and we need to scale the data operation around it. So that's amazing. Also, infrastructure and platform engineering that we had. And finally, we are recruiting, as you can imagine. We are recruiting for my team. We are looking for senior AI engineer that also have very strong engineering capabilities and also research capabilities. We're going to publish the job very soon, but you get first glimpse from it. So if you think you are relevant, feel free to send your CVs to me. And that's it. Any questions?